Hello, everybody. Welcome to a short session in which we're going to talk about how projections of solids can be taught or rather solved on a software like SolidEdge. Okay. Before we get started, it is imperative that everybody has gone through the videos in which Dr. T. and Sridhar has described how projections of solids is actually done. You need to learn how to draw the orthographic projections of solids before you actually do them on a software like this. That said, the software that I'm using here is just a version or so older than the one that you normally use in class. But most of the commands are the same and they just look slightly different, but they all exist in the software. The first problem we're going to solve is of a hexagonal prism of 20 millimeter sides, base sides that is, and an axis of 60 millimeters. It's resting on the VP such that its axis is inclined at 60 degrees to the VP, whereas the edge on which it rests on the VP is inclined at 45 degrees to HP. Okay. One thing you'll have to note throughout this video or the next where we work with SolidEdge is that I will be skipping and editing in a few things that you guys would have already learned. The basics like how to draw a hexagon, which you may use a which may use a circle method. I'm going to skip over that. I'm going to skip over all nomenclature and some of that I'm mentioning because nomenclature itself is going to take a long time. I do not want to waste your time showing you the nomenclature. So you will get screens in which suddenly nomenclature for all the points will appear. So we start off with a problem with a hexagonal prism. So because the axis is inclined to the VP, we assume it is perpendicular to the VP so that we can see its true shape in the front view. So that is where we're going to start from first. So like any problem, we start off with the XY line. Next, we create our hexagon in the front view. Okay, as I said, I am going to skip the bits and pieces of the sketches to make your life a bit more interesting, or rather less boring. Anyway, so the hexagon is drawn in the front view. Remember, this is a hexagon that represents the top base of a hexagonal prism. And because it's a prism, it will have a top base and a bottom base, meaning the top base or the points on the top base will hide the points at the bottom base. So when you get to nomenclature, it's going to look slightly different. There you go. From the magic of editing, we have now created hexagon and marked all its points. Okay, just like Dr. T has told you, we always start from the left extrememost point. If you're starting from the front view, we draw or name the points in a clockwise direction. If you start from the top view, we do it the other way around. Anyway, this gives you your front view perfectly. Remember, only the edges of the sketch that you actually need. So in this case, the hexagonal prism need to be dark. Everything else needs to be thin. So thick edges of 0.5 millimeters for the edges, thin lines of 0.13 millimeters for everything else. Okay, so right now you've got your front view, and from the front view, we're going to project the top view. Like I said, again, we draw projectors from all the points like so. And one other thing as well is I have drawn diagonals to mark the center of the prism, which basically means I've found out where the position of the axis is going to be. Okay, so we're going to go away again and be back with the top view. There you go. Now you have the top view of the object. And just like every other problem you're going to do, your observer is going to be up here. Looking up from there, where the cursor is right now, the observer is going to be able to see the edge, the lateral surfaces represented by A dash, B dash, B1 dash, A1 dash, B dash, C dash, C1 dash, and C1 dash. That means those are the rectangles, or rather, those are the rectangular surfaces which will be visible to the observer, meaning that the points F, T, and E, D1, E1, and F1 would be invisible. Also, one thing you will normally forget to do is mark the axis. However, because the edge PB1 is going to come over the axis. We are not going to mark the axis itself. We're just going to name the points O1 and O in the top view. So BB1 is perfectly collinear with OO1 in the front view, meaning you'll be able to see BB1 rather than OO1 in the top view. Okay. Next, the problem says the axis is inclined at 60 degrees to the VP. I know in the drawing sheet or on the drawing boards, you'll need a bit of time to do all the inclination and stuff like that. Here, it's going to be a lot easier. So you select the entirety of the top view. When I say entirety, I mean everything, the nomenclature, the dimension I forgot to mark, everything. So you select the entirety of it like so. Use the move command. Make sure copy is on. I hope you guys have learned this in the second chapter, or rather the third chapter on projection of planes, and place it like that next to the image, or next to the first stage top view. Next, we need to provide it with an angle of 60 degrees. So again, I go to rotate, I switch off copy, and remember, the question says it's resting on a base edge. And let's say the base edge on which it rests is C1, D1. So that is the edge on which the object is going to rest. And from there, I've got to lift it up to a given angle. Okay, so all I need to do is enter the value and stop it like that. So right now, your object is rotated by 60 degrees, the second stage that is. Immediately after that, remember, as soon as you finish any sketch, the first thing you do is provide it with the nomenclature. And there you go. The axis is now inclined at 60 degrees to the VP. It is resting in such a way that the edge C1, D1 is on the VP, whereas nothing else is on the VP, and the axis is inclined at 60 degrees. So from here, we need to redraw, or rather recreate, the front view in the second stage. So how do we do that? We identify which base is closer to the observer, the top base or the bottom base. So remember, we have the observer right here. Whenever we are trying to recreate the front view from the top view, the observer would be wherever the cursor is right now, meaning that the observer will be closer to the points A, B, C, D rather than the points A1, B1, C1. That implies that the base A, B, C, D is going to be visible, whereas the base A1, B1, C1 is going to be invisible. And that is where you start the sketch from. Okay, you guys, and rather all of you have a tendency to draw all the projectors in one row and then recreate the sketch on the second projection. But what I want you to do is project one point at a time rather than everything. So from A to A dash, you get a line, and I want you to stop here. I do not want you to draw a line that goes beyond the entity. Then you have from B to B dash. So drop it right there and not further. Then C to C dash, that's here. Okay, then again D to D dash, which would be here. E to E dash, which would be here. Obviously, F to F dash is already done because F and D lie on the same line. Meaning you have, let me just zoom in for a second to make your life a bit easier. So, meaning that you have the points A dash here, B dash here, C dash here, D dash, E dash, and F dash. Okay, I'll just mark the point O dash as well for the sake of convenience, which we'll get to later. So that's the top base covered, meaning that this is the base that is going to be visible for your problem. Okay, so if you want, you can do the same thing for the bottom base as well. As you can see, the bottom base is very, very close to the top base. That is, one point of it is going to be exactly on the same line. So we're going to do that. So D2, D is here, and C is there as well. So you have D1 dash here and C1 dash here, right on the same point. Then you have P and E. So you have E1 here, B1 there, A1 here, and F1 here. So once all that is done, again, you go back and you name the points. Yeah, as this is the first problem, I'm spending just a bit of time naming the points. The further we go, the lesser time I'm going to spend naming all these points. So that's E, and the last point is F. So obviously, the front view in the second stage is not going to come out just like this. It needs a bit of line thickening and identifying the boundaries, so on and so forth. Just marking the points is nowhere near enough. So we know that the top base here, ABCD, is going to be visible compared to the bottom base. So that's where we start our sketch from. Remember, you need to worry about the procedure rather than worrying about imagining how the object is going to look like. So procedure says we make the visible base thick first. So from A dash to B dash to C dash to D dash and E dash and F dash and A dash. That's the bottom base. Next, we darken the boundaries, which is B1 dash, A1 dash, F1 dash, E1 dash, and E dash. Next, we darken the longer edges. The longer edges would be F1. The reason I'm starting from F and F1 is because since point F is visible and the point F1 dash is visible, that means the line joining F1 and F is definitely going to be visible. The same thing holds true for the points C1 and A1. Next, we need to draw, or rather, A dash and A1 and A. Next, we're going to go to BB1, which is already withdrawn. Then CC1. So C is here, C1 is here. Obviously, here you come across an issue because this is a line that goes through the visible base, meaning that this particular line is not going to be visible, which we identify as a discontinuous line like that. So I'm just deleting the previous projection line and marking it as a discontinuous line like that. Remember, there are a few cases in which a real line is going to be identified as a discontinuous line because it is invisible. Either you have a line behind a visible base, like in our case right here, where we know that the point A dash, C dash is visible, but we also know that the point C1 dash is invisible. The reason C1 dash is invisible is the observer looking at it from here definitely is going to realize is going to be furthest away from the point C1, which is part of the base on which the object is resting. So C1 is invisible, whereas C is visible. That means the line through that is definitely going to be invisible. The other thing you have to also know is whenever two lines intersect, one of them is always going to be invisible. In this particular case, CC1 is intersecting with AA1. We know that AA1 is visible. We also know that AP is visible, and we also know that AF is visible. So we have four lines intersecting, of which 3 lines are visible. So obviously, CC1 is going to be invisible. And the same theory holds true, or the same hypothesis holds true for the other point, DD1, which you're going to mark in a discontinuous manner. So we have now come across 2 different types of lines. One is a visible line, which is a continuous line of 0.5 millimeters thickness. Okay. Then there is an invisible line, which is a discontinuous line of 0.5 millimeters thickness, but the line type is the second one, which here is identified as a dash. Okay, so the last thing we need to identify is the axis. So the axis is going to be projected from the point O1 and O, which comes here. So let me just name them for the sake of convenience. So O1 is going to be here, or rather O is going to be there, and O1 is going to be here. So the line joining these two is going to be your axis. So the axis line is going to be identified slightly differently compared to the other two lines. We are not going to use a continuous line nor a discontinuous line. We use the one down here, which is a dash followed by a dot. And we also make this 0.35 millimeters thick so that we can make out the difference compared to the other lines. So this is what your object or your problem should look like if you solve it for just inclination to the VB. And this is what your second stage front view should look like. You should have marked all the points correctly. A dash, B dash, C dash, D dash, E dash, and F dash are visible. So are the points E dash, or rather E1 dash, F1 dash, A1 dash, and P1 dash, because they make up part of the boundary. Remember, we are not dealing with any sort of imagination. We are going to follow the procedure. We identified the visible base, which is A dash, B dash, C dash, D dash, E dash, and F dash. Next, we darken the boundaries. B dash, B1 dash, A1 dash, F1 dash, E1 dash, and E dash. After that, we darken the longer edges, which are visible. Longer edges basically meaning the lateral edges. A dash is visible and A1 dash is visible, meaning the line joining the two will also be visible. Same thing holds true for the line F dash. Next, we draw the other missing longer edges, CC1 dash, D dash, D1 dash. We know that C1 dash and D1 dash are invisible points, whereas C dash and D dash are visible points. So the line joining a visible and an invisible point is always going to be invisible. Okay, so this is what your second stage looks like. The third stage asks us to provide an inclination of the object with respect to the HV. We know the question says the edge on which the object rests, that is CC1, is inclined at 45 degrees to the HV. So we select the whole sketch, we say move, we move it from one point to the next, like that. Make sure copy is on. Then, without doing anything else, we hit the command to rotate. So CC1 is the edge, or C1D1 rather, is the edge on which it rests. All I need to do is rotate it to a given value. So the given value is 45 degrees. I rotate and I click, it automatically rotates to my given position. That's it. That's done. Your rotation is done. As soon as you finish the rotation, remember, marking the axis is paramount, or rather marking the angle is paramount. So that's stage 3, front view. All you need to do to finish the problem is draw the front view for the, or rather the top view for the last stage. Okay. So just like before, we follow procedure rather than the imagination. So procedure tells me that you have the observer, who is right here where the cursor is going to be closer to the base A dash, B dash, C dash, E dash, and F dash rather than A1, B1, and C1, meaning that this is going to be the visible edge, and that is where I start the sketch from. So from the point A, which is here, to the point A, which is down there, I draw a horizontal and a vertical projector. So from the horizontal from B to a vertical on P dash, like so. Then vertical from C to a horizontal from C, like that. Then D, remember C and D lie on the same horizontal. Same thing is true for E and B, which is over here. Then F and A lie on the same line. Oops. F and A lie on the same line. So that gives you your top view. So what I'm going to do is, before I even head further, I'm going to name all the points, and this is how I want you guys to do it in your exams as well. So as soon as you finish one view, or rather one edge, one base, name the points. It makes your life a lot easier. Okay, A, B, C is there, T is there, E and F. Okay, the names in the week vicinity is more than enough. Once you've done with this, make sure you finish the sketch right here. Okay, so let's say make it a thick continuous line, because I know it is a visible edge. So from A to B to C to D to E to F, and then back to A. So that is your visible base taken care of. So what we're going to do next is take care of the invisible base as well. So same as before, just make sure the line is thinner. These are all just projector lines. So you have A1 and A1 dash. Same thing holds true for F1 and F1 dash. Remember, the line, or rather the edge C1 D1 rests on the XY line, meaning you have D1 right here and C1 right here. That is because the object is described as resting on the VP. If it is resting on the VP, it means that that particular edge is going to appear on the XY line in the front. So you've got A, F, C, and D. The only thing that remains is B and E. There you have B. And the last thing you need to do is A, B, C, D, and E. Okay, so here's E. I mark E, like so. Okay, so that was just appeared as an inclined line. I'm just going to draw it as straight line. Any unnecessary lines can easily be trimmed away with the trim command, like so. Okay. You know, one thing I have left out in the second stage front view, and I should just notice now, is the line B1, C1, D1, and F1. Obviously, these are going to be real lines, so 0.5 millimeters thick, and they're definitely going to be invisible, because even though B1 dash is visible, C1 dash is invisible. Same thing holds true for D1 and E1. And because you have A dash F dash, which is a visible line intersecting or overlapping C1 D1, that means AF is going to be given priority, and that is going to be shown as visible. So let me just fix this as well. Now we can go further. So with this done, all I need to do is go back to my original procedure, which says once all the points are named, all I need to do is draw, identify in which, or rather identify which base is visible, the top base or the bottom base, which I've already done. I know that the base A, B, C, D, E, F is going to be visible, which I've done. Next, I'm going to draw a line, which is going to mark the boundaries of the sketch, which is A, A1, sorry, which is going to be A, A1, B. Again, my apologies. Remember, this kind of a thing shouldn't happen. Make sure everything is right. So it has to be a 0.5 millimeter thick continuous line from A to A1 to B1 to C1 and D1, then E1. Sorry, from D1 you go to D. Oops. D1 to D. So this is going to be your boundary. Next, you're going to draw the longer edges. AA1 is already done, so BB1, since both B and B1 are visible, that's fine. Same thing holds true for C1. We've already marked DD1 because it's part of the boundary. Okay. Next, I'm going to worry about EE1, and it is not going to be visible purely because EE1 is going to intersect CD, which I know is a real visible edge. That means E1 is invisible. That also means the line E1 D1 is invisible. Same thing holds true for E1 F1 because it intersects with C1 CC1, which is a visible line. Then again to F1 A1. Then the last longer edge that's remaining is FF1. So with this done, all that remains to be done is mark the axis. Okay, so marking the axis is pretty straightforward. So remember, continuous thin line from O1 here to O1 there, from O up there to O down here, and then from these 2 points I mark a line and I give it its required line thickness and line type. Line type is going to be dash and a dot. Line thickness is going to be 0.5 millimeters. So that's your completed sketch. Okay, so this is how your problem should look like. They should have all relevant information without any confusion or ambiguity. Okay, there should be a difference in line thickness between your projection lines and your axis lines and your final sketch lines. Anything, there should be perfect distinction. Normally what I recommend to my classes is that we make the construction lines or the projector lines gray in color. Here you can clearly see a clear difference. I've just grayed out all the construction and the projector lines in the last stage rather, and you can clearly see a difference between the final stage and the first two stages. Your object is going to be much clearer if you make the construction lines gray rather than black. So anyway, I know this is quite a long video and I do thank you for your patience. You need to go through this once more if you need. You need to solve as many problems as you want. You will be given quite a few problems to solve by your class teachers through your Google Classroom pages. So have a look at that. Make sure you talk to your teachers on a regular basis so that your doubts will be solved. Okay. Thank you very much, everybody. Good luck with the rest of the problems.